Hello, my name is Matthew Stern. I'm going to be going through chem problems for the final, 29 through 33. So 29 says a microwave oven uses electromagnetic wave at a wavelength of 12 centimeters to heat foods by making water molecules vibrate. Calculate the photon energy in units of microjoule. We have the wavelength of 12 centimeters. We want photon energy in microjoule. So first you convert the centimeters to meters. So 12 centimeters times 10 to the negative 2 meters over centimeters. The centimeters cancel. We get 12 times 10 to the negative 2 meters. In scientific notation, decrease by 1, increase the exponent by 1. We get 1.2 times 10 to the negative 1 meters. Then what you want to do is find the frequency by getting speed of light, which we know, and dividing it by wavelength, which we got here. Speed of light, 3.0 times 10 to the 8th meters per second, divided by our wavelength, 1.2 times 10 to the negative 1 meters. Meters cancel, we're left with 1 over s. The frequency is 2.5 times 10 to the 9th. 1 over seconds. Photon energy is Planck's constant times our frequency. Planck's constant is 6.6 times 10 to the negative 34 joules per second. And then we want to multiply that by 2.5 times 10 to the 9th, 1 over seconds. The seconds cancel. We're left with joules. We're left with 16.5 times 10 to the negative 25 joules. In scientific notation, that is 1.65 times 10 to the negative 24 joules. We want our answer in microjoules, so this is 1 over 10 to the negative 6 joules. That's the conversion from joules to microjoules. Joules cancel. Our final answer with the correct significant figures in scientific notation is 1.7 times 10 to the negative 18th microjoules. This is the correct answer, the last one, and the other ones are the wrong value. During a rainstorm, rainwater with a mass of 6.00 times 10 to the 3 grams was collected in a rectangular container. The container has a length of 30 centimeters and a width of 15.0 centimeters. The density of rainwater is 1.00 grams per centimeters cubed. Assume the container is deep enough to contain all of the water collected. Calculate the height of water collected in the container in centimeters. We know the mass equals 6.00 times 10 to the 3 grams. We know the density is 1.00 grams per centimeters cubed. And then we know also the width and the length. We want the height. So starting off, we know volume equals mass over density. So our mass is 6.00 times 10 to the 3 grams divided by our density 1.00 grams per centimeters cubed. The grams cancel and our volume is 6.00 times 10 to the 3 centimeters cubed. So then we're going to use this formula, volume equals length times width times height, to find our height. So we now have our volume is 6.00 times 10 to the 3 centimeters cubed, and that equals our length, 30.0 centimeters, times our width, 15.0 centimeters, times height. Isolate for height, you get 6.00 times 10 to the 3 divided by 450. That means you get 133, and in scientific notation, that's 1.33 times 10 to the positive 1 centimeters. Is correct answer. The other ones are the wrong value. 31. At a social gathering, an infected person coughs out 3.3 times 10 to the negative 9th milliliters of microscopic droplets of lung fluids. The microscopic droplets contain 3.0 times 10 to the 11th virus particles per milliliter. Calculate the number of virus particles in the cough. We have 3.3 times 10 to the negative 9th milliliters times 3.0 times 10 to the 11th virus particles per milliliter. Milliliters cancel. We're left with 9.9 times 10 squared virus particles. This is the correct answer. The other ones are the wrong values. 32. An electrical power plant generates electricity by using the heat energy produced by combusting a fossil fuel. For each joule of electrical energy generated, the power plant emits 5.00 times 10 to the negative 1 milligrams of carbon dioxide. A family lives in a house with a solar roof that covers 1.25 times 10 to the 3 square feet. Each square foot of the solar roof typically generates about 4.00 watts, joules per second, of electrical energy. Calculate the mass of carbon dioxide in kilograms prevented from entering the atmosphere by the solar roof over a period of 4.32 times 10 to the 4th seconds. Step 1, calculate the energy generated by the solar roof. We have first, we want to get the square feet, 1.25 times 10 to the 3rd square feet times 4.0 joules per second per 1 foot squared, 1 square foot. The square feet cancel, times 4.32 times 10 to the 4 seconds. The seconds cancel, we're left with 2.16 times 10 to the 8th joules. Step 2, calculate the CO2 saved by the solar roof in kilograms. We 2.16 times 10 to the 8 joules times 5.00 times 10 to the negative 1 milligrams of carbon dioxide per joule. The joules cancel, times 1 times 10 to the negative 6 kilograms over 1 milligram, because we want the answer in kilograms. Milligrams cancel. Our final answer is 108 kilograms of CO2, and in scientific notation, that's 1.08 times 10 to the 2 kilograms of CO2. And then the second one is the correct answer, and the other ones are the wrong values. And the last one, 33. Gasoline is a mixture that contains hydrocarbons. Many of the hydrocarbon compounds have 5 or 6 carbon atoms. A typical passenger car holds gasoline that contains 30 kilograms of carbon. When the fuel tank is empty, all of the carbon carried is burned. Calculate the mass of carbon dioxide that will be emitted into the atmosphere in kilograms. Assume no residue remains, and the carbon dioxide is the only product. So we know 30 kilograms times 44 grams of CO2 over 12 grams of carbon. We get that from the table. Solve that out. That's 110 kilograms of CO2. And in scientific notation, it's 1.1 times 10 to the 2 kilograms of CO2. The last one is the correct answer. And the other ones are the wrong values. Okay, thank you.